last but certainly not least is dividing polynomials. The reason that this one is certainly not least is because it actually combines everything that we've been talking about with adding, subtracting, multiplying, combines it all into one big deal. What we're going to do though is just recall something that we know about fractions. You might remember that with fractions we can't have square roots in the denominator. We also can't have imaginaries, and so essentially what this problem is going to be doing is just getting rid of the imaginaries in the denominator. To do that, we're going to need to multiply the multiply the numerator and denominator by the complex conjugate of the denominator that you see here. So what is a complex conjugate? Well, it's a number that is in complex form, like 2 plus 6i, and it has a partner, and that partner is just the same thing except we change the middle sign. So plus goes to minus. The only thing we change between these two is the positive and negative. So if we're looking for the complex conjugate of negative 2 plus I, what we're going to do is we're going to multiply this by negative 2 minus I. Those basically go together. Now, if we're not going to change the value of this problem, we also have to multiply the top by the exact same thing. That's just the consequence here. And so now we've got two multiplication problems. Now the reason I multiply by this complex conjugate is because of the special relationship they have. If we do things right, what's going to end up happening is that the denominator is going to just turn into a real number, and it is okay to have a real number in the denominator. We got a FOIL. Negative 2 times 2 is 4. Negative 2 times negative I is plus 2i. I times negative 2 is minus 2i. And then I times negative I is minus I squared. Now, good news about this one that you can probably see already is that the two i's cancel out. That's how this method is going to work. I squared, or negative I squared, since I squared is negative 1, negative 1 is just positive 1, so we got plus 1 on the bottom. That means that the bottom here is just going to be 4 plus 1. Just doing all the way through on the bottom before I get into the top. So the denominator ends up being 5. The numerator isn't going to be quite as nice, but we can deal with it. It's, again, going to be foiling, so we've got 3 times negative 2 is negative 6. Then 3 times negative I is negative 3i. Negative 2i times negative 2 is plus 4i, and then finally negative 2i times negative I is going to be plus 2i squared. All right, we can combine like terms. This 2i squared, since I squared is negative 1, 2i squared is just going to be negative 2. Then we can combine negative 6 minus 2 is negative 8. Negative 3i plus 4i is positive 1i. And we get this answer here, this negative 8 plus I over 5. Now we're almost done there, but this is going to ask us, many problems here are going to ask us to do it in standard form, which is a plus bi. So to get this in the form of a plus bi, I just have to split it up. So that's negative 8 over 5 plus 1/5 I. That's just the same exact thing as this, but technically in standard form instead. And so you're going to want to go to that point to match up with the answers that the book provides.